Good morning, students. Today we are going to start a new topic, that is topic number 9, coordination compound. Now here, this is completely new concept. We have seen covalent compound, ionic compounds, that is salts. Covalent compounds we have seen in organic chemistry, that is the compounds which are formed by the sharing of electrons. They are called as covalent compounds. The compounds which are formed by the electrostatic force of attraction are called as ionic compounds. Now we are going to see the coordination compound. Now these coordination compounds or naturally occurring coordination compounds are chlorophyll. That is, this chlorophyll is present in plant leaves, which is used for in photosynthesis. Now this coordination compound, that is this chlorophyll, is the coordination compound of magnesium. Then hemoglobin, which is present in blood. This hemoglobin is the coordination compound of iron. Now these are naturally occurring coordination compound. Chlorophyll, hemoglobin, then vitamin B12 is also a coordination compound of cobalt. Now we know the common salts, that is NaCl, KCl. Now when these common salts undergo dissociation in water, they forms ions. When they undergo dissociation, they form Na plus and Cl minus ions, or K plus and Cl minus ion. That is, this Cl in NaCl satisfy the primary valency of this sodium, and this chlorine or Cl minus ion satisfy the primary valency of potassium. Now we are going to see the example of some coordination compound. This is PtNH3 2 times Cl2. This is a first example. Coordination compound is generally written in the square bracket. Then here this is second example, CONH3 6 times Cl3. Now here this is coordination sphere. CONH3 6 times, it is a coordination sphere, and this Cl3 satisfy the primary valency of this cobalt, and therefore it is written outside the square bracket. Like NaCl, this Cl satisfy the primary valency of sodium. Similarly, the oxidation state of cobalt is +3, and this Cl3 or 3Cl satisfy the primary valency of this cobalt. Now these coordination compounds possesses this CO or Plt, in this example platinum, and in this example this is cobalt. Now these two are central metal atom or ion. Then here this NH3 or Cl, or in this case this NH3, these are electron pair donor ligands, called ligands. These ligands or this NH3Cl2 or NH3 donates a lone pair of electron to the central metal atom or ion, and therefore they are called as electron pair donor ligands. Now this is the structure of coordination compound, and this Cl3 is a counter ion which satisfy the primary valency of this cobalt. Now we can understand the structure of this coordination compound by using the example of CONH3 6 times Cl3. This is the structure of coordination compound. Now here this is cobalt. Now in coordination compound there are two spheres of attraction. First is inner sphere of attraction, which is called as coordination sphere or non-ionizable sphere, and second is outer sphere of attraction, which is known as non-ionizable sphere, which satisfy the primary valency of the central metal ion. In coordination compound, central metal atom or ion have two types of valency. First is primary valency, and second is secondary valency. Now here in this square bracket, the secondary valency of cobalt is satisfied. That is, in coordination sphere or in inner sphere, this cobalt is bonded to 6 NH3 group, which 6 NH3 group satisfy secondary valency of cobalt. That is, secondary valency of cobalt is satisfied by 6 NH3 group, and primary valency of this cobalt is satisfied by this Cl3, that is 3 chlorine. Now here the components of this coordination compounds are cobalt, that is central metal atom or ion. This cobalt is central metal atom or ion. In inner sphere, this cobalt is bonded to 6 NH3 group. This NH3 group donates a lone pair of electron to the cobalt and forms a coordination bond. This is a coordination bond between cobalt and NH3, and this bond is represented by an arrow, and this arrow is pointed to the central metal atom. This is because this NH3 group donates electron pair to this cobalt, that is, transfer of electron takes place from ligand to or from NH3 to cobalt, and therefore the bond between ligand and metal ion is shown like this by this arrow, and this arrow is pointed towards the central metal ion. This is central metal ion and this is ligand. Now here the bond between central metal atom and ligand is a strong and rigid bond which cannot easily break, and therefore this sphere is called as coordination sphere. And or it is also named as non-ionizable sphere, which satisfy secondary valency. Now these 3 chlorine which are present outer sphere, these 3 chlorines are present in outer sphere, and when we dissolve this CONH3 6 times Cl3 in water, then it undergoes dissociation and gives 3Cl minus ion. The bond between cobalt and NH3 is strong bond and it does not undergo dissociation and will get 3Cl minus ion, and therefore this Cl minus ion satisfy the primary valency of this cobalt, and this sphere is called as ionizable sphere. Which satisfy primary valency of cobalt. This is the structure of coordination compound which possesses central metal atom or ion, that is cobalt, then ligands which are present in coordination sphere, that is this square bracket. The components which are present in square bracket are called as coordination sphere, and then this Cl3 which satisfy the primary valency of central metal ion. That is, in coordination compound there is presence of central metal atom or ion, then ligands and the ions or atoms which satisfy the primary valency of central metal atom. In coordination compound, the interaction between central metal atom or ion and ligand seems like a acid-base interaction. We are going to see the acid-base interaction between central metal atom or ion and ligand. Now we have seen that the central metal atom or ion accept electron pair from the ligand, and then formation of this bond between metal and ligand takes place. That is, this coordination bond seems like acid-base interaction because this ligand donate a electron pair to the central metal atom, and therefore this ligand is electron pair donor Lewis base, and this metal ion or atom accept electron pair, and therefore it is electron pair acceptor Lewis acid. That is, this interaction between metal and ligand bond or formation of coordination bond between metal and ligand seems like acid-base interaction, because here metal ion accept electron from ligand and therefore acts as a Lewis acid, and ligand donates an electron pair to the central metal atom or ion and thus behaves as Lewis base. Now we are going to see next point, ligands. What is meant by ligands? The electron pair donor atom or molecule which donates electron pair to the central metal atom in coordination compound are called as ligands. That is, the bond between metal and ligand or electron pair donor atom or molecule is nothing but coordination bond, and this electron pair donor atom or molecule is called as ligand. That is, ligand is electron pair donor atom or molecule in the coordination compound which donates electron pair to the central metal atom or ion. Now there are three types of ligands. In which first, monodentate ligands. That is, the ligands which donate only one pair of electron to the central metal atom or ion are called as monodentate ligand. For example, Cl minus ion, Br minus ion, I minus, OH minus ions, Cn minus ion. These are the negatively charged ions which donate electron pair or only one electron pair to the central metal atom. Now, some ligands, monodentate ligands, may be molecules. For example, NH3. Now, this NH3 possesses, this is ammonia molecule which possesses a lone pair of electron on nitrogen atom, and this lone pair of electron can be donated to the central metal atom or ion, and therefore it is, or this ammonia is also example of monodentate ligand. Then H2O. In H2O, this oxygen atom possesses a lone pair of electron which can be donated to the central metal atom or ion in coordination compound, and therefore this water molecule is also an electron pair donor ligand. Now these are the monodentate ligands which can donate only one electron pair to the central metal atom or ion. Now second, polydentate ligands. Polydentate ligands means the ligands which can donate more than one electron pair to the central metal atom. Either they can donate 2 electron pairs or 3 electron pairs, etc., etc. That is, the polydentate ligands are those which can donate more than one electron pair to the central metal atom or ion are called as polydentate ligand. Now here there are some examples are given. Now this is ethylene diamine. First example is ethylene diamine. Now in ethylene diamine, now this is CH2, CH2. This is ethylene, and one hydrogen atom from this CH2, CH2 is replaced by, or one hydrogen atom from this ethylene group is replaced by NH2 group, and therefore it is ethylene diamine. Now here these are two amine group, therefore it is ethylene diamine. Now here this nitrogen atom can donate electron pair to the central metal atom, and therefore they can donate a two lone pair of electron to the central metal atom, and therefore it is example of bidentate ligand. Then here this is oxalate ion. This oxalate ion possesses negatively charged two oxygen atoms. That is, these two oxygen atoms can donate electron pair to central metal atom, and this oxalate ion can donate two pairs of electron to the central metal atom, and therefore these two examples are of bidentate ligand. That is, these two examples are of bidentate ligands. This ethylene diamine and this oxalate ion can donate two pair of electron to the central metal atom or ion, and therefore these are examples of bidentate ligands. Now this is ethylene diamine. Third example is ethylene diamine tetraacetate or EDTA. Ethylene diamine. Now this is ethylene group. Diamine means 2 NH2 group. Now here tetraacetate. Tetra means 4 and acetate group. Acetate group means CH2COO group. This is the acetate group. Now here all these two hydrogen atom from this NH2 group and this NH2 group are replaced by this acetate group, and then it becomes CH2COO minus CH2COO minus. Then here also CH2COO minus and CH2COO minus. That is ethylene diamine tetraacetate. Now here this ethylene diamine tetraacetate can donate electron pair to central metal atom like this 1, 2, 3, 4, 5 and 6. That is, this ethylene diamine tetraacetate donate 6 pairs of electrons to central metal atom, and therefore it is called as hexadentate ligand. That is, this ethylene diamine tetraacetate is hexadentate ligand which donate 6 pairs of electrons to the central metal atom or ion. These are the examples of polydentate ligand. Polydentate ligands donate more than one electron pair to the central metal atom. For example, ethylene diamine. This ethylene diamine can donate 2 pairs of electron to the central metal atom or ion. Therefore, it is example of bidentate ligand. Then this oxalate ion which donate 2 pairs of electron to the central metal atom or ion, then it is called as bidentate ligand. And this ethylene diamine tetraacetate donate 6 pairs of electron to the central metal atom or ion like this 1, 2, 3, 4, 5 and 6, and therefore it is hexadentate ligand. Now we are going to see third type of ligand is ambidentate ligand. Now ambidentate ligands are the ligands which can get attached to central metal atom through 2 different atoms like this. For example, thiocyanide. Now this is thiocyanide. Name of this ligand is thiocyanide, that is SCN. Now this SCN can attach to central metal atom through sulfur. That is bond between sulfur and metal is formed, or bond between nitrogen and metal is formed. That is, the ambidented ligands can attach to central metal atom through the two different atoms. That is, in this case, this metal get attached to this SCN by forming bond with sulfur, and in this case this metal get attached to this thiocyanato by through nitrogen bond. That is, nitrogen metal bond is formed in this case, and in this case sulfur metal bond is formed. This is called as thiocyanato and this is called as isothiocyanato. This is the example of ambidentate ligand. Now second example is nitro group. Now this nitro group can get attached to central metal atom through nitrogen. That is, bond between nitrogen and metal is formed, and in second case bond between oxygen and metal is formed. That is, this oxygen atom of nitro group get attached to central metal atom, and here the coordination bond is formed in between metal atom and oxygen. Now this is nitro and this is nitroso. These are the example of ambidentate ligand in which central metal atom get attached to ligand through various atoms. These are the various types of ligands.